Hello and welcome to the Futures Currency Trading demonstration using the Temporal Relational Extension, also known as TRE. If you have any questions, you can contact me on tredatabase@gmail.com. Before we begin the demo, I'd like to explain a few of the principles behind TRE. You begin with the business data that you wish to model. If you factor the time away from the data, you're left with a current view schema in which to develop. We think this is the most natural and efficient way of working with a relational database. The only thing that TRE demands of you is that before you run your insert, update, deletes or selects, that you set the time so that TRE knows what the context of the command is. Even though you're working in the current view, TRE leaves behind a complete bitemporal audit with complete referential integrity at all points in time. It provides multi-version reconsistency and locking in time. This is the schema that we're going to work with. It's 4 tables: clients, positions, securities and trades. A security has a mid-market end of day price. Trades have quantities and exchange rate. And trades are grouped into a position being defined by the end date or the value date of the first trade that comes in for a particular security and client. A position is created and the trade is placed into that position. So we see here that we have, for example, 3 trades and 1 position. The first trade was traded, and because there were no positions for that trade, a position was created for it, and then subsequently trade 2 and 3 over the same value date and therefore going to the same position. The start time of a trade is also known as the trade date, and the end time is also known as the value date. Because we've got TRE, once our data is in the system, we can query by setting a crosshair effectively at any valid or transaction time, so we can see the state of the database at that time. This is an example of the report that investment banks produce at the end of each day at close of business. The current P&L position is calculated based on the mid-market end of day price. It takes into account all the trades that have occurred for a particular security and shows the profit or loss made so far on that day. Quite often though, after the report has been sent out, late trades occur and corrections occur, and a subsequent report has to be sent out for the same trading day, and of course there has to be a reconciliation between the original report and the new report that was sent out a few days later. We now move on to the demo, and you can see I'm already connected into a Oracle database. I've got a script to run. This is just to remind you, this is a TRE running the end of day client trading report based on the mid-market end of day price of securities. We've got 4 tables. We're going to be working in the current view, and we're going to provide a full bitemporal audit of the operations that we've performed, and this script will show that later on. So we begin by just setting up our timestamp format and for presentation only, and we create some script variables to record dates into. So we'll record our transaction time before we do a late trade, before we delete a trade, before we reinsert a trade, and before we correct the traded rate. And we also have some script variables for our valid times. We'll use these transaction timestamps later on to go back when we're doing the bitemporal audit. So we begin by just giving values to our valid times. So we're going to start our client on the 1st of January 2000. The first trade is going to be traded on the 6th of June. Second trade on the 21st of June, and so on. Our end dates, or our position, the end dates of our positions are going to be the 9th of September. So initially the trades are going to be put into position 1 on the 9th of September, and then we're going to create a second position on that finishes on the 8th of September, and our 2 reporting dates are going to be the 29th and 30th of July. We begin by generating a temporal version of the current view design. And once we've generated our temporal schema, we have a view for every current view table, for every table in our current view design. So we have a view for clients, securities, positions and trades. You'll notice that the same number of columns exist in the view, the temporal view, as does the original table design. Additionally though, TRE provides an extra view. We're showing here the trades Z view. It has the same columns as the trades view, but it also additionally has these timestamp columns that TRE maintains for us. This isn't for the developer to maintain, this is just for presentation only. If you want to see the start of existence, that's held in SOE, the end of existence held in EOE, the start of a valid version of the record in SOV, and the transaction timestamp YTS held in YTS. There is a situation where we allow the user to update the SOE or the EOE, start of it or end of existence. That's if they want to alter the insert time of a row or the delete time of a row. But typically these are just for presentation only. As I said earlier, TRE demands to know the time, so we'll initially set the time to now for both valid and transaction time. And we see, because we've just started with an empty database, that we've generated no clients, no securities, no positions, no trades. We need to begin by creating our lookup data, so we're going to create a client and some securities. So we set the valid time of TRE to VT start client, and we insert the first client portfolio company New York. We're also going to create 4 securities to trade in. You'll notice that we now have a client and 4 securities. You'll also notice that the mid-market end of day price does not have a value at the moment. That's simply because we've just created them. Typically at the end of each day, the mid-market end of day price will be updated, and therefore the report will take account of that value. We'll be doing that later in the script. So we begin by receiving the first trade. The first trade that comes in on the 6th of June has an end date of the 9th of September, and because there are no positions for that particular value date, we create the position. So the position is defined by the first trade that's in there, which starts at VT trade 1. So we set TRE to be at valid time trade 1, and we insert a position 1 for client 1 Australian US dollars. Because we know the end date of the trade, it's a futures trade. We know the end date of the position, so we move to the end date of the position, which is the 9th of September, and we end the life of the position, i.e. we delete the position. We now have a position at the point at which we just deleted it. At this valid time there are no positions, but if we go back to the beginning of life of that position, we see that we have our position waiting for us to place trades into. We now have a position, so therefore we will start putting the trades into that position. So we begin by going to the valid time of the first trade, 6th of June 2005, and inserting trade 1 into position 1, sell 1.801 million at a particular exchange rate. What's happened here is that the TRE has allowed us to insert the trade date. It's inherited the trade date from the valid time that we've set, and it's inherited the value date from the position that we've put the trade into, position 1. Time moves on and we receive the second trade. We insert the second trade into position 1, a buy of 241,000. Time moves on and we receive the third trade on the 14th of July 2005 at 11:30. So we set the valid time for TRE and insert the third trade into position 1, a sell of 391,000. Again, with all these inserts, the fact that we've inserted a trade into a particular position means that it's inherited the end date of that position through referential integrity. If we now look at the If we now look at the select statement for the P&L report, it's a simple current view select statement joining trades, securities and positions by ID. We can see that we're using the trade Z view because we want to present to the report the trade date, the dates, i.e. the start of existence and the end of existence of the trades, also known as the trade date and value date in this case. We can see that we've sold 1.8 million, bought 241,000 and sold 391,000 of this particular security. They're going to be traded, their future value date is the 9th of September. Okay, if we now just quickly interrogate the database at different valid times, if you go to the valid time of trade 1 and run the same report, we see that at that time there was one trade. If we move along to the valid time of trade 2, the same report provides 2 trades. If we move to the valid time of trade 3, we run the report again, exactly the same sequel gives us 3 trades as we would expect. You'll notice that there's no P&L inception value because there was no mid-market end day price for each security, so there's nothing to calculate. So typically in a real system, at the end of each day when we receive the mid-market end of day price, we would update the security with that mid-market end of day price. So if we go to the first report date that we're interested in showing, the 29th of July, and update the mid-market end of day price for Australian US dollars. If we now run the report, we'll see that when we join to the securities table at that valid time, we now have a mid-market end of day price, and therefore the calculation produces a P&L. We've got 2 reporting dates, the 29th and 30th of July, so if we move to the second reporting date now and update the Australian US dollar security with a new mid-market end of day price, run the report, we can see now that a new calculation for those 3 trades has been created for us. We can move back to the original date, so if you go back to the 29th of July, run the report, it's now taking the mid-market end of day price as at 29th of July to provide our P&L. Okay, so all is well, all the trades have been received in the correct chronological order and we've sent our reports out. Occasionally we receive a late trade and we have to rerun the report. So first of all, as we receive the late trade, before we do that, we're going to just make a quick note of the transaction time in this physical database so that we can go back to it when we're showing the bitemporal audit later on. So make a quick timestamp, and now we deal with the fourth trade. So we go to the valid time of the fourth trade, 20th of July, and we insert the fourth trade into position 1, a buy of 1.951 million. That nets us back to 0. You'll notice that the start time has been inherited by the valid time that we set TRE at, and the end time has been inherited by the position that we've placed the fourth trade into. So the fourth trade has had cascaded down its end date from the position that we placed it into. If we now run the report on the 30th of July, we see now that we have 4 trades. The 20th of July has been inserted into the correct chronological position. If we just go to the valid time, the 30th of July, but just before we did the late trade, this is the report that we sent out before we received the late trade. This is the first report that the customer would have received, and we need to be able to reproduce that report so we can reconcile against the now correct version. So therefore we can reconcile the reports. If we go to the, just to show that, if we go to the 29th of July, valid time report 1, and current transaction time now, we can see that we have 4 trades. The P&L for the 29th of July gives us a value of, for example, 5486 for the first trade. If we go to the second day, transaction time now, we have 4 trades, the P&L now being recalculated for the new mid-market end of day price. If we go to the 29th of July valid time before we did the late trade, we see that we now only had 3 trades. We hadn't received the late trade by this time, And if we go to the 30th of July valid time before we did the late trade, we can see that this is the report we sent out before the late trade, the P&L being generated by the value of the mid-market end of day price at that time. Okay, so you may have noticed that those positions ended in 2005 valid time. So if we go to valid time now, transaction time now, and run the report, there are no open positions. But even though we are at a valid time of now, we can still report on old positions from this valid time if we wish to. TRE provides other views that I haven't mentioned up to now that gives us a valid time history of any entity that we have in our design. And we can use those to run those sorts of reports. So let's now move on to the next stage, which is to correct a mistake. We've dealt with a late trade, but we now need to correct a mistake. Let's say, for example, that the second trade that had an end date of the 9th of September was incorrectly sent to us, and really its end date was the 8th of September. That means for us a new position should have been created for that second trade. So we will process it as now. We'll reprocess it as if we had received it correctly. So we need to create a new position for that second trade. That position will end on the 8th of September rather than the 9th of September, so it's the second position. Its end date is the 8th of September. So therefore on that valid time we have now deleted that position. At the time of the report, 30th of July, we now have two positions available to us in which our trades can exist. We're now going to correct trade 2 by going to the start time of trade 2, the 21st of June 2005, and just updating or reparenting the trade by setting its position to 2 where the trade ID equals 2. If we now run the report as of the 30th of July valid time, we can see that the second trade traded on the 21st of June 2005 has now been grouped into a new value date. It's inherited the new value date through referential integrity by placing it into position 2 that ends on the 8th of September, and the other 3 trades are still in a position that ends on the 9th of September. Okay, so that's the first kind of correction, reparenting. The second kind of correction is that in fact the second trade should not exist at all in any other valid time. We're going to expunge it from existence in the whole of valid time. So before we do that, we're just going to make a valid transaction timestamp before we delete, so we can go back to it later in the bitemporal audit section of the demo. We go to the valid time of the trade that we want to delete, and we delete it. That removes it from the existence in valid time. If we now run the report, see what we have for 30th of July, we now see that because we've removed the second trade, we now only have 3 trades in the system. If we go to the 30th of July before we deleted that trade in transaction time, we had 4 trades, and the second trade was in fact value date 8th of September, as we expect. Next kind of error is that we want to reinsert that trade. We want to reuse the business key. It's valid to insert trade number 2 at this transaction time because there is no trade with that business ID at this transaction time because we've just deleted it. So we can reuse the business key and reinsert at this transaction time, right now, trade 2 we want to reinsert. So before we reinsert, we'll just take a quick transaction timestamp. We'll now set our valid time to the time of trade 2, and we will insert trade 2 into position 1, a buy of 241,000. Again, it's inherited its start time from the valid time that we set at, VT trade 2, and it's inherited its end time from the end time of the position that we've placed it into, position 1. If we now run the report again on the 30th of July, transaction time now, we see that trade 2 has slotted itself back into position 1 ending on the 9th of September. This is the report that is true now after the reinsert. Before the reinsert, this was the truth. We had just deleted trade 2 from position 2. Finally, the other thing that could occur, of course, is that we could alter the values of any of the non-identifying attributes, in this case the traded rate. So before we do that, we'll just make a quick timestamp. We will now set ourselves to the start of the trade 2, the one that we want to change the exchange rate for. We update the exchange rate of trade 2 with a simple update statement. If we now set ourselves to the valid time of the 30th of July and run the report, we can see that the traded rate now for trade 2 is 0.749, and therefore the P&L has been altered accordingly. If we go back to the transaction time before we did that traded rate change, we can see that the traded rate was 0.77785, and therefore the P&L has a slightly different value. We achieved all this with very simple insert, update and delete statements in the current view. You may have noticed that when we insert a trade, we have to check to see whether a position exists already for it, for that defined by its end date. And if one doesn't exist, we have to create a position, and this of course could be put in a simple application API. The code that would be in that API has already been shown to you in this demo. Very straightforward. So finally, even though we've processed all these transactions in the current view, we have a quite sophisticated result in the sense that we can do a full bitemporal audit and 100% reconciliation of all the states that we had our data in at any point in transaction or valid time. For example, we can go to the 30th of July valid time before we did the late trade. And before we did the late trade, we had 3 trades in the system. On the 30th of July valid time, before we deleted the second trade, we had moved the trade into position 2, ending on the 8th of September. Before we reinserted the second trade, we had removed it from the position 2. Before we had updated the traded rate, it was in position, it had been reinserted back into position 1, and its traded rate was 77785. And if we look at the report as we know it right now, we can see that it is in the right position with the correct traded rate, and this is the report that we should be sending out to our customer. So, in conclusion, what you've seen is a futures currency trading demo that produces a real result as produced by investment banks at the end of each day. It provides 100% reconciliation of the state of the reports that you sent out. It allows the investment bank to produce bridging reports showing the reconciliation between the report sent out on, say, Monday and the subsequent report sent out on Thursday, with corrections made because of late trades or cancellations or whatever. It's all been done in the current view. Developers would find it very easy to produce such a system. There is no complication as far as the developer is concerned. They just work in the current view and they get a complete bitemporal referentially correct database. Thanks for listening. Hope you've enjoyed the demo, and if you have any questions you can contact me on tredatabase@gmail.com.